Okay, so looking at lesson 1 here of the second unit, basically chemistry is going to be the study of matter and changes it undergoes. We're going to look at it many different ways this year. So periodic table comes from very important meaning. It means that it comes from arranging trends in different ways. We will look at that more as the year goes on. But periodic table contains everything that in the universe I should say, is made of. Everything is also made up of mass and volume. So we're going to go ahead and look at those two qualities a lot this year. So a couple definitions. So matter is anything that contains mass and volume. Elements would be the names given to the items in the periodic table. Element symbols would be their symbol. So if it has two letters as a symbol, the second one's always lowercase. So something like sodium has capital N lowercase a. Formulas is going to be that elements combined, they form compounds. Compounds made up of more than one element. It may be two of the same element, but just made up of more than one. When we say substance, we're talking about generally any element or compound. And a mixture is going to be two or more substances are in the same system, but they're not bonded together. So an example here would be salt water. Okay, we're going to discuss this more later as well. So first task here, we're just going to identify things as elements, compounds, or mixtures. So if we look here, we've got H2O2. So whenever you see something that's made up of more than one more than one element combined, that's going to be a compound. Okay, so this is a compound. Now, even though bromine is an element, there are more than one of them, which makes this a compound. Salt would be NaCl or something like that. Compound, water, H2O. Oxygen as is just an element. This is obviously made up of more than one element together, so that would be a compound. Iron 2 oxide, iron and oxygen has to be a compound. Copper is an element. So when we look at something like H2SO4, or I should say H2SO3, there's more than one element there. Obviously, that has to be a compound. O3, compound, there's more than one oxygen. Sand would be a mixture. You can't really write a formula easily for it, so it has to be a mixture. And nitrogen would be an element as well. All right, so if we look at the next thing here is subatomic particles. So you probably have heard this many times before in science classes. There are things called protons, neutrons, and electrons. We are going to kind of talk more about these this year. For right now, we're just going to use the method you've talked about, which looks like this. I'm assuming neutrons and protons are in the nucleus and so forth. Electrons are around. You hopefully know the charges: protons positive, neutrons neutral, and electrons are negative. We're going to kind of work on these a little bit more here with the numbers on the periodic table. So the atomic number is going to be the smaller number, and it's generally found on top of the element. So you're going to see it in the upper left or right, or even in the middle of the different kind of cell it's in on the periodic table. It's going to indicate the number of protons and number of electrons if it's neutral. The mass number is going to be the larger of the two. If you subtract those two numbers, you're looking at the number of neutrons, okay? So we're going to kind of work on filling out this table. I'm going to do one as an example for you, and you can work on the rest. So if we look at sodium, the atomic number of sodium, if I look, it's above sodium on the periodic table. So the atomic number we are looking at is 11. For sodium, because I didn't tell you a charge or anything, so you can assume it's neutral, the atomic number is 11, which means it has 11 protons by definition. Since it's neutral, these two should be the same. You need the same number of pluses and minuses basically to cancel out. The mass number for sodium, the one below, if I round that to the closest number, it's going to be 23. If I subtract the mass number and the atomic number, the difference there would be the number of neutrons. So 23 minus 11 is giving us a difference of 12. Okay, so go ahead and give another one or two of these a try so you know for sure what we were talking about today.